Ladies and gentlemen, please welcome the former Vice President of the United States, Mr. Al Gore.
Thank you. Thank you very much. Thank you, ladies and gentlemen. My colleague and partner, the co-founder of Climate TRACE, Gavin McCormick, is with me, and we're going to be presenting together today. It's a great honor, of course, to be with all of you, and for those of you who have devoted so much of your lives and so much time to this effort, thank you very, very much. As you know, so much depends upon it. We have a lot of material to get through, so I'm going to go ahead and start on this. And as usual, I start with the Earthrise and the blue marble photo. But if I was ever going to give a slideshow, this is the slide that I would use, because it shows the thin blue shell that surrounds our planet. Most of you are aware of this. It's blue because that's where the oxygen is, and that's also where all of the global warming pollution is. And it's so thin that if you could drive a car straight up in the air at Autobahn speeds, you'd get to the top of that blue line in about 5 to 7 minutes. And that's what we're using as an open sewer for all of the global warming pollution that we are putting into it at the rate of 175 million tons every single day. And on average, each molecule, various lifetimes for different substances, but on average, the molecules stay there about 100 years. So it builds up and it congregates, and the largest source of all that pollution, of course, is the burning of fossil fuels, 80% of it. And if you notice that notch in the upper right-hand corner, that is the pandemic. And when the pandemic hit, the emissions went down 6%, and then the following year it went right back up again, 7%. And the next notch down, that's the global financial crisis of 2008. Now, the total amount that is up there traps as much extra heat every day as would be released by 750,000 first-generation atomic bombs exploding every single day on our planet. That's an incredible amount of energy, and that's, of course, what's causing all of the disruption and the damage. And last year, the scientists are still trying to take account of how off the charts everything was. You hear that same phrase over and over again for air temperatures, sea temperatures, ice melt, the Canadian wildfires, and coral bleaching, many others, off the charts. In fact, there was an important column by two distinguished scientists just a couple of days ago saying they're still trying to figure out why it got hotter than they really expected it to. But as you can see from this graph, the temperatures have been going up quite steadily. Last year was the hottest year ever measured, and both NASA and Copernicus have said that even though we have 6 weeks or so left in this calendar year, this year is going to be even hotter than last year. The 10 hottest years ever measured have been the 10 hottest years, and 2024 will take its place as the hottest, and the new 10 list, 19 of the 20 hottest have been the last 20. The pattern is extremely clear, and so we're seeing people go to extreme efforts to try to keep cool, and the damage is quite severe. If you look at the heat wave in Delhi, almost 50 degrees during their election earlier this year, a lot of people died, and of course, tragically, 1,300 people died in the Hajj this year because of the extreme heat. And as a result, we are seeing many parts of the tropics and subtropics begin to change, not only where the temperature is concerned, but also the humidity, and the combination of that feels-like temperature, as some people call it, is making larger areas of our world physiologically unlivable. And in fact, if you look today, there are relatively small areas that are uninhabitable, unlivable, meaning if you're outside for more than 2 or 3 hours, you die because the body can't cool itself off. But because of the current trends with the climate crisis, we're seeing these areas grow quite dramatically. And if you look at India, for example, it's difficult to imagine, and Pakistan, and some of these other areas, we're already seeing the out-migration of climate migrants, and the world could see up to 1 billion climate migrants this century, according to the Lancet Commission. And if you think about how bad the political knock-on consequences of a few million have been and triggering xenophobia and ultranationalism, it's difficult to imagine what 1 billion climate migrants would be. My religious tradition teaches me, as most religious traditions do, to welcome the stranger and welcome the refugee. But my previous lifetime in the political world taught me that too many in too short a period of time can be disruptive to self-governance. Now, stepping back and looking at the world as a whole, 93% of all this extra heat is absorbed in the oceans, and it's quite dramatic to look at how much of it is going into the oceans, because it goes 2,000 meters down and even deeper, and astonishingly, half of all of this increase has been in the last 20 years. And if we don't do something much more than we're trying to do now, then this will double again. And the consequences are completely unacceptable. We have to face up to this. We have to. And I think people pretty much realize that. And as the oceans heat up so much, they give a lot more water vapor up into the sky, and the warmer air holds a lot more water vapor. For each degree, it's a 7% increase in the holding capacity of the atmosphere. And so these atmospheric rivers are already, the average atmospheric river equals 27 Mississippi rivers, 90 Danube rivers, and when they come over the land and the conditions trigger a downpour, the downpours are much larger. They're called rain bombs by many scientists now, and we are seeing this in every part of the world. And just 2 weeks ago in the Mediterranean, if you look at the sea surface temperatures in the Mediterranean a couple of weeks ago, that's 2023 and this is 2024, the end of October, that's when the hot Mediterranean started giving up so much water vapor, and it comes in the atmospheric flows over Valencia, and you saw what happened in Valencia. It was just a horrific tragedy. More than 200 people were killed by it. Thousands of homes died. It started in the wee hours of the morning, and you saw the sun come up in this video. Now the sun's gone down, and it's still raining there. It started raining again a couple of days ago, and as a result, we just saw incredible chaos and damage, and 217 people killed, and of course there is now a desire for a reckoning there in that province. This is a similar situation just a few weeks earlier in near my country in the Gulf of Mexico. That's the average water temperature for the previous 10 years. That's last year, and that's the water temperature for this year. And on September 26th, that's when Hurricane Helene became a massive super hurricane, slammed into Florida and went all the way north up to a region near where I live, but North Carolina got the brunt of it, and you saw more than 226 people. There were 226 people killed there, and this region has been severely damaged. The same week in Nepal, roughly the same number of people were killed by the massive rain bomb that hit Nepal. More than 200 people killed in Nepal by this event. And the same thing happened in Nigeria. You can go around the world, and of course, Typhoon Yagi in Southeast Asia killed more than 500 people. And I could pick these examples and show you this happening all over the world. And I used to say this happened 5 years ago, this happened 10 years ago. Now I say this happened last week, this happened 2 weeks ago, because it's getting worse. It's getting a lot worse quickly, and will continue to get worse until we as humanity decide to organize ourselves well enough to take action. That's what we're supposed to be doing here at this COP. Same thing happened last May in Brazil. This is by far the worst flooding tragedy Brazil has ever had. This region, people are worried that it may not be able to recover. Devastating tragedy. 169 people killed, 600,000 people moved from their homes. This region may not recover. I hope it will, of course, and the people there are resilient, but it's a great challenge. And of course, my dear friend Simon Steele, who all of us love and admire at this organization, his home island in the Caribbean was absolutely devastated. This is one of his neighbors' homes here, and he said it's unchecked climate carnage in every country on Earth. Now, that same extra heat that's being trapped by the global warming pollution that increases the water vapor and causes the downpours and floods and mudslides also pulls the moisture out of the topsoil and makes the droughts much worse. This is a NASA slide that measures, these two satellites measure gravity. It's quite a clever experiment, but what it shows is both the flooding events and the drought events are increasing simultaneously. And you can see the amplitude of each is getting larger as a function of the rising temperatures. And again, this is going to get worse too. The fact that the scientists who predicted all of this decades ago have been proven dead right should cause the rest of us to pay more attention to what they're telling us now. Do we listen to the polluters who don't want to do anything meaningful that might reduce fossil fuels, or do we listen to the scientists who have been telling us what we need to do? This was an extreme drought in China in the middle of this year, and what's happening in the Amazon, the Rio Salome, the Rio Negro. It's the worst drought on record in the Amazon. 90% of the river flow in Colombia is gone. Ecuador's losing its hydro because of this. In Namibia and also Zimbabwe, they're now killing livestock, killing wild animals in order to help feed hungry people. How long are we going to let this get worse until we decide to take action? I'm sorry, I press my own buttons these days. And the more the temperature goes up and the more the drought gets worse, the more the fires spread and get worse. They've doubled in the last 20 years, and this is this year. This is right now, really, in North America, and it's really quite a catastrophic situation. This is in the Amazon, where they had a record number of fires this year. This is the Acropolis. Some of you may have seen this on the news, and the Prime Minister of Greece says, we're at war. Climate crisis is already here, and the wildfires in Europe and the Mediterranean last year have been really catastrophic. The cost is going up as well, $3.25 trillion in the last decade. That's an increase of $600 billion over the previous decade. This too will get worse. When will we decide that we don't want to keep paying to clean up and try to heal the consequences and deal with the causes instead? Now, of course, you know the ice in the Arctic and Antarctic is melting. Greenland had temperatures earlier, last year, 28 degrees above normal. Greenland is now losing 30 million tons of ice every hour. During the hour that we're in this room, 30 million tons will go from Greenland. That is fresh water coming off Greenland into the North Atlantic, where a key part of the ocean current circulation system is involved. It could be disrupted. Some scientists disagree, but more and more they're raising the alarm. And if you look at the bottom statement, these scientists say in this peer-reviewed study, we estimate it collapsed around mid-century. What? Some of the load-bearing elements of our entire Earth ecological system are at risk. And what are we doing? Just talking away, not making much progress. Again, I'm getting stirred up here, so I'll try to calm down. I'm going to hand it to Gavin here in a minute, and he'll maybe take the temperature down a little bit. Antarctica, where there is much more ice, you can see the steady accumulation, steady rise of the amount of ice that is melting. The Economist had this cover back in April, a $25 trillion loss predicted by mid-century. In 25 years, 15% of all the housing stock in the entire world at risk. Should that get our attention? When are we going to wake up? When are we going to take action on this? River deltas are becoming salinated before the water comes over the shore. It invades the root zone. There are many agricultural river deltas that are being affected. But in lakes and inland seas, like the Caspian, for example, the increased evaporation, other factors, but the levels are reducing in these inland seas and lakes, and the Caspian is very much at risk. They are predicting another decline of up to 18 meters in this century, devastating the economies of the countries, including this one. And of course, it's also an extinction and biodiversity crisis. So, here we are. Are we going to keep using this as an open sewer? We need to understand where it's all coming from. That's where Climate TRACE comes in. You look, most of this global warming pollution stays below 5 kilometers. You can see it's so thin. That's our open sewer. But you can't pick out where it's coming from these kinds of measurements. You can only manage what you measure. And that is, we know the basic sectors, but we have not been able to identify exactly and precisely where it is coming from. That's where Climate TRACE comes in. And each one of these columns here is a large polluting source. You can click on every single source in the entire world with Climate TRACE. We have a coalition of 12 members, and we have more than 100 contributors. Thousands of people are working to make Climate TRACE more and more effective every single month, and you can see the list of our contributors here. And we have been very fortunate to have worked with scientists who are really validating every aspect of Climate TRACE. Gavin McCormick, my co-founder of Climate TRACE, take it over.
Thank you. So,
I'll be back.
So again, Climate TRACE is not an organization. It is a coalition of over 100 collaborating organizations. Now, why are we doing this? I am one of many, many scientists who has expertise in one part of emissions. My particular expertise is power sector emissions. There are other groups in the coalition that have expertise in shipping emissions, forestry emissions. And I, like many, feel a fierce urgency to pick up the pace of what science can tell us and technology can do for us about not just measuring the problem, but finding what can be done about it and making it happen. So the nature of Climate TRACE is the idea that science works best when you bring many, many different methods together, and technology works best when you combine many, many different data sets together. And so just like you have no one author to Wikipedia, the idea of Climate TRACE is we are combining many different methods from greenhouse gas science, from classical inventories, from integrating top-down and bottom-up emissions inventories, from AI, into a single system that allows us to get a more rapid, more complete, more actionable inventory of emissions that we can do something about. So by bringing this together, we are finding that one of the most rapidly upgradable forms of emissions measurement is artificial intelligence. An example of one of the most common techniques we do. If you look at the pictures in the upper left, what we've done there is we've combined information from satellites that are deploy satellite imagery at scale to monitor all the many, many, many facilities that do not have individual sensors every hour. As a result, we have been able, by combining all these many groups, to measure 660 million of the largest individual sources of pollution worldwide. This is essentially now a comprehensive inventory of everything in the world that emits. And what we've done is we've put it all together into a single website, and I want to draw your attention to the number on the left. 60 billion tons of CO2 equivalent every year is actually higher than any previous emissions inventory, and that's because we are seeing sources of emissions that were present in one inventory but missing in another. We're seeing dark vessels that are trying to hide from regulators. We're seeing landfills that the government did not know about. We're seeing corporations whose emissions are off the books. By combining all of these data sources, we've got the most complete picture of emissions ever. This is all free and available to the public. And what it has allowed us to do is get an inventory of every sector in every country. And so just to give you a quick example, we're here in Baku. Anybody can go to climatetrace.org and zoom in on Baku and get a sense of emitting facilities in the area, and you can do this for anywhere in the world. You can zoom in on individual facilities, you can see a refinery, you can see a steel plant, and we have very detailed information. For example, you can see the emissions changing over the month. You can see the uncertainty and confidence in numbers. You can see different types of emissions, and in the metadata, useful information for experts such as the size of the facility or its emissions factor. By bringing this all together into a database, we are getting really good insights and improving our information every year about different sectors. Just thought I would give you one example of new information in the sector. So automated identification systems are the transponders that ships use to not crash into each other. They're also increasingly used by emissions experts to estimate the emissions of ships. But we are seeing a rise in ships that are deliberately turning off their safety equipment, called dark vessels, in order to avoid embargoes, or illegal fishers will often do this. By bringing in a new climate trace contributor this year, we were able to add a new technology using visual identification instead to detect all those dark vessels, and that's combined with an existing contributor, OceanMind, who uses AIS systems. By pooling these resources, we're able to make sure that facilities cannot hide from the complete picture. For context, about 7% of shipping emissions, or something as large as the emissions of the nation of Ireland, are now dark vessels, and we're making upgrades like this all the time. By bringing this all together, we are pleased that we are now able to move from annual information to monthly information. So if you will go into the Climate Trace database, you will see emissions that happened up to each month, and we've got our estimates of the next 2 months to make annual comparisons possible. But the big thing that we wanted to share today that is new is we've been able to get such comprehensive measurements now, we're moving beyond just countries. So we are proud to share today that for every state, every province, and every county in the world, we have been able to collectively build an emissions inventory. I would like to really emphasize that the vast majority of states worldwide do not have the resources to have an emissions inventory. So we are not talking about wealthy countries that have a lot of data, we are talking about the entire world. And what we see is that for many states worldwide, the current state of the art is you look at the national inventory, which might be a couple of years old, there might be some sectors missing, you figure out what share of the country you are, and you kind of assume that your states of emissions are similar to the national average. But we routinely see examples of 3 bordering states. 1, the largest source of emissions will be electricity. 1, it will be buildings. 1, it will be oil and gas. Those states do not want to look at the same policies to reduce their emissions. With more actionable information, you can move faster to figure out better ways to reduce emissions.
And just as there are different emissions patterns and volumes between different states in the same country, there are also very different emissions profiles within the same industry, depending upon the facility, depending on the technology. You can have as much as 16 times as much pollution from a blast furnace steel operation compared to an electric arc operation. Same with aluminum, same with these other examples that you see here. And by switching out suppliers to replace high-emitting suppliers with much lower-emitting suppliers, many of the large corporates who are now using climate trace data are able to cut their emissions significantly by just changing out their supply line. They frequently save money in the process as well. And we're hearing from a lot of these states and provinces that we're working with at Climate Trace. This is Jalisco State in Mexico. It's been great to work with. Also in the Western Cape, they have also been a valuable partner in Cordoba, in Argentina, another example of how we're working with them. And in addition to the states, provinces, and counties that Gavin talked about, we have virtually all of the cities in the world. I say virtually all because in some examples, it's kind of hard to say what's a city and what's not. Where are the boundaries? But we have everything that most people call a city, 9,000 of them, and we have detailed databases for all of these 9,000 cities in the world. And by the way, for 80% of them, it's the first inventory they've ever had. And we have had some surprising findings. These cities that have never had an inventory account for 25% of all the emissions. Some cities that do have an inventory, like New York City, for example, they don't include their big airports in the New York area. We do. We can give you the precise emissions amounts and profiles for every one of these cities in the world, including cities you might never have heard of in Madang, Papua New Guinea, and Nepal, and the others there. Now, this is another innovation that we're introducing this year. Thanks to our new contributor, Carnegie Mellon University, they've done such a great job on this. We are now able to track and measure the non-GHG pollution, including the particulate pollution that makes people sick and kills so many people around the world each year, that comes from the same combustion process that also causes the global warming pollution. The World Health Organization has identified 7 of these as being of particular significance, and you can read them for yourselves. We have now traced 75% of all of this pollution right back to the individual millions of sources where it is coming from. And it's quite revealing when you drill down and look at this. This is prior to when we put this data together. Most countries have not had an inventory of their non-GHG pollution. Now they do. We're giving it to them today, and we'll continue to update it monthly. 8.7 million people per year killed by the pollution from burning fossil fuels. Have we just gotten used to that? Is that just a fact of life that we're willing to accept? We can stop that. We can shift to the cleaner, cheaper, better sources. I'll get to that in a moment. But this is where the disease burden and the death toll is greatest in these countries. But it's also true that in major countries, in developed countries, certain regions also have a much higher disease burden and death rate. You may have heard of Cancer Alley. It is a long stretch, 85-mile stretch of the Mississippi River between New Orleans north to Baton Rouge, and there are petrochemical facilities along either side of it and refineries. What does it look like? You can see the concentration of pollution in these areas, and we have the health statistics now for these areas. But the analysis is much finer grain than this. Here's an ExxonMobil facility. The green represents areas where the population is predominantly black. 2/3 of the population in Cancer Alley is black. And look at this. If you live in this area, you understand why some people have called it a sacrifice zone. The people who live there, okay, we'll just sacrifice them in an important respect. Can you imagine? And of course, the people who live there have been screaming about this out loud for quite a long time. And this goes on every day, every night. You look at one of these communities in the middle of Cancer Alley Reserve, Louisiana. What do you think the health problems are in that area? Well, that city has the highest cancer rate in the entire United States of America. 50 times as much cancer per person as the nation as a whole. This is another consequence of continuing this ridiculous and suicidal dependence on fossil fuels. Now, the health disparity, the median age is more than 6 years lower. Look at Pittsburgh. Here are some examples from Pittsburgh, Steel City. And you can see the particulate pollution, again, going to these areas. And predominantly, a lot of it goes into the areas where black, brown, and indigenous people live. And the life expectancy there has gone down as well. Tell them about Jane Burston.
Thank you. So in the United States, in some cases, these data have already been available, but for many countries in the world, this is brand new information. So that's why we're excited with support from Clean Air Fund to be able to look into these air pollution and environmental justice issues on a global scale. And so to give you an example, in every different country around the world, we've been able to track for the first time where is non-greenhouse gas emissions coming from, and we're beginning to model what neighborhoods are breathing that. So these are actual airflows. This is hourly information about the direction of wind speed at that time, modeling out literally who was breathing what pollution from these facilities around the world. And what we see is there are systematic patterns of disparity at every scale. So for example, in the EU, we are not used to talking as much about disparity between EU member states, but Denmark is significantly wealthier than Poland per capita, and we see very, very similar patterns in the data at this scale. So in Poland, we see a much higher concentration of coal plants and other coal-burning facilities. And if you are living in one of these plumes, your exposure to these pollutants is significantly different in nearby, wealthier Denmark. We see similar patterns at every scale, but just for a sense of what that means, a baby born in Warsaw, Poland today, 1,000 cigarettes worth of pollution they will breathe in their first year of life. That's a very different outcome than someone living in Denmark for a very similar set of economic circumstances. And we also find this in the developing world where there has been less science done to date. So for example, we're looking at a region in South Africa that has intense concentration. 100% of all coal plants in this heavily coal-dependent country live in the same region. That's Mpumalanga province, which translates to land of coal in Zulu. And so it is one of the less wealthy areas within a country that has fewer resources. It has a higher population. It has a higher black population than, for example, Western Cape province, which is wealthier. And we see similar disparities of emissions intensity and exposure to pollutants within the country. And so across states, across countries, across continents, we see this systematic relationship in the data between wealth, often race, and exposure to pollutants.
And by the way, you know, this whole debate over carbon markets, I'm not going to get into it. They have to play some role, and you'll sort out the details. But here's what cannot be allowed to happen. You can't tell people who are living with this flow of particulate pollution, driving the cancer rate 50 times higher, oh no, we're all good because we're planting some trees in another country. You have to continue living with this pollution. This problem needs to be addressed in a holistic way. But what we can do is actually focus on the developing countries and prioritizing where we site the new clean energy facilities. Some of the more responsible companies around the world are actually gaining credits and benefits and reputation by building new renewable energy facilities in the areas where it will do the most good and reduce the most emissions. If you're building a new energy facility in a place that already has it, then that's something else. But look at this. The single state of Florida has more solar panels than the entire continent of Africa. This is a disgrace. This is a disgrace for our world community. Africa has 60% of the solar potential of the entire world. Africa has solar potential that is 400 times greater than the potential of all of the fossil fuel reserves they think are located in Africa. And yet, this pitiful result, because they're walled off from access to private capital on equal borrowing rates so they can participate in this clean energy revolution. We need to change this on an urgent basis, because it's getting worse. If you look at the developed countries, the global warming pollution is going down. In the developing countries, it's going up. 100% of the increased emissions going forward are going to be in the developing countries. If you look at the particulate pollution, the same pattern. Going down in the wealthy countries, still going up in the poor countries. We have to fix this. If you look at where you can site a new renewable energy facility, this is an interesting graphic here. The blue thing, that shows avoided emissions. If you put a brand new solar facility in this area near Joburg, then you are avoiding a lot of greenhouse gas pollution. If you put it in Los Angeles or in California, it's a good thing, you want to do that, but you're not getting the benefit of reducing the global emissions in the same way that you will by focusing on the developing countries. Some companies are doing this. I'm very proud of Apple. I used to be a part of Apple for 21 years. They are using climate trace data in order to site new renewable energy facilities in areas of the world where it will result in the largest reduction in global warming pollution. And of course, that also reduces the particulate pollution. And a lot of the people that we've been working with are very kind. Project Drawdown, which you all know very well. You know Jonathan very well also.
Yeah, so I've always been a fan of Project Drawdown's approach of what climate solutions work better than others. And so we're excited to be working with Drawdown as one of the folks looking at this data to say how can we move faster by choosing particular projects, particular locations, using data like this to move faster with the same resources. And so just to give you an example of how this works, we can see with Climate TRACE data, Berkeley County, South Carolina, we see the same heavy concentration of coal plants that have always been there. But a different region, Council Bluffs, Iowa, we can see from space solar panels going in and coal plants being converted to parks. But both of these have data centers. And so if you were to use data and electricity in Iowa, you are now adding less pollution than if you were to do the exact same thing in Berkeley County, South Carolina. And so we're starting to work with different users. One of the most interesting is 2 Sigma, a financial services firm in Wall Street that uses an enormous amount of artificial intelligence because they execute many, many trades daily. They have looked at Climate TRACE data and been able to identify that by moving artificial intelligence use from one area to another, they can actually reduce the emissions in an overburdened community and barely cause an increase in the other community. And so there is an improvement in the climate potential, but also in equity and also in health. So we're really excited about applications like this to allow people to move faster and do better. Another example of a Climate TRACE user that's very interesting is NASA's Jet Propulsion Laboratory. So what they've figured out is the difference between the old system of looking at emissions in the atmosphere and assuming where resources happen versus actually detecting where real facilities are can increase the accuracy of climate models. For a sense of context, this is what most of the world's space agencies do when they are looking at emissions. They will look at how much is in the atmosphere and they will use a proxy to allocate where do we think that came from. The most famous example is nighttime lighting. So if you look from the Earth at night, you can see pretty well more or less where emissions are coming from because factories and cities are bright and forests are not. So this is a very common technique, but what NASA was able to figure out with this is that there are flaws in it. So that widespread technique, for example, can miss cases like the Alberta tar sands, where they cause 11 times more emissions than nearby Calgary, but at night they don't light up as much. And so if what you're doing is you're assuming that wherever the light is where the emissions are, you will get a pretty good sense of emissions, but we're working with them to get a better sense of emissions and to figure out exactly where is it coming from.
Yeah, and by the way, if you didn't, I don't want you to miss a salient detail. When NASA's climate modelers are saying that Climate TRACE data is better than what they were using, and they're getting the best results by using Climate TRACE, that's kind of a validation in my view, because I really respect those women and men at NASA. Let me go back to this. These are some of the users of Climate TRACE data, and we're working with C40 and the Interparliamentary Union, the Under 2 Coalition, and you can read for yourself. The Climate Reality Project, Phyllis Cutno, our president and CEO, is here. We're going to have a meeting later, and we're very proud to work with these users. Now, the governors of states and provinces have been key allies, and some of them have done an amazing job. I want to introduce one of them to you now and bring him out on stage. Governor Jay Inslee of the U.S. state of Washington is the most effective climate policy implementer in the entire United States among governors. And he just had a resounding victory in the election. Not everything in the election went the way I wanted it to go, but in Washington, they had a big victory in continuing this fantastic reduction of emissions. And Jay, come on out here and tell us what's in store. Great. Good. Yeah, it is.
I'm Jay Inslee. I'm governor of the state of Washington. We're in the northwest corner of the United States, represent 8 million people. And I just want to say this to start with. I have officially, with my wife, the 6 cutest grandchildren in North America. And their best friend is right here, Al Gore. Give it up for a guy who's only won 1 Nobel Peace Prize, but he's still doing some good work. I came to share 2 brief messages. Number 1, despite the election results at the White House last week, We are moving forward in America big time. We have momentum that will not be slowed down, will not be retarded, and I can do things in my state that I can tell you unequivocally that Donald Trump cannot stop, and his election will not stop the action in the United States of America. And the reason for this is that we have states, counties, cities, nonprofits, 5,000 in the Americas all in, 24 states in the U.S. Climate Alliance, the Beyond Oil and Gas Coalition that are all in their own way working and making progress dramatically. And what Al just talked about, the climate deniers tried to repeal the nation's best cap and invest bill last Tuesday. We beat them 62 to 38. The climate deniers got their fannies whipped, okay? I just want to make sure you understand that. Second mention, I think the reason Al invited me to this, and it is an honor to be with him and his whole team. This trace technology, this plume technology is not a secret weapon, it is a supremely successful weapon in the war against climate change. And let me tell you why I say that. I'm a practicing politician. I've been in and out of it for 30 years. And we know something that's very true, and it harkens back to, if I can quote Muhammad Ali, is that okay to? I'm going to quote Muhammad Ali. Muhammad Ali says, you can float like a butterfly, sting like a bee, but a man can't hit what he can't see. We now can see the enemy against us of CO2. We now can vector our energies against it. We can go to our constituents and show them in a graphical way it is hurting not some far-off distant continent on a far-off distant decade, but their own children. This is a tool to show the threat to our own children. And when they see this tool in city council races and community races all across the United States, politicians are going to have to yield to this technology. Seeing is believing. That's the news. I will tell you, America's in it. We're going to use Al's tool big time. So, Baku, we're with you.
Thank you, Jay. Yeah, you take that with you. Thank you very much. Jay, you are absolutely great. And I want Gavin to tell you, here's an example of how we can use the climate trace data to prioritize the reduction of emissions to get the biggest bang for the effort.
So it's actually two ways. So the first thing we can do is we can detect now where are facilities that could be doing something better. So climate trace data has been able to find what we believe is every landfill in the world, and we can look at which landfills have been covered, which landfills have not been covered, and a key way to reduce methane is just literally don't have the trash going out into the open atmosphere. And so a simple thing you could do is we've been able to identify, for example, 100 sites, but you could do now 9,000 sites if you wanted, and just covering these just covering these 100 largest sites in the world would allow us to reduce over 2 million tons of methane pollution. But there's a second thing we can do. We can actually say, what if instead of going for the largest landfills, we went for the most impactful landfills? By looking at which landfills have not yet been covered, by looking at which landfills have a type of trash with a higher emissions factor, with the same effort, you can actually get 70% more methane reduction. Instead of going for the largest landfills, going for the landfills that we can do better. And what's really interesting is what we see in the pattern is it is no coincidence that those landfills are almost always in communities that are less wealthy. Why? Because we see a lot of patterns like this in the data. Depending on the technology type of that emitting facility, it has a different emissions factor. If you have a clay cover, that's even better for reducing methane than, say, a sand cover, which is cheaper. And so the richest areas will often have clay covers. They're a little bit better at reducing emissions. But the bulk of emissions come from the difference between doing nothing at all or doing the cheapest, simplest thing. And over in the data, what we see is that overburdened communities where there have been no resources is where nothing at all has been done. And the fastest way to reduce GHG emissions is to put resources in these communities, which will also heavily reduce the pollution burden that causes disease. Just to give you an example of how this relationship works. So this is a map of different landfills around the world. Let's look at this landfill in Lagos, Nigeria, that is completely uncovered, an extremely high emissions factor. You can visually see why. Nothing has been done. Let's compare this with a landfill in Kentucky that has been covered with a cement and has a very low emissions factor. It doesn't even really matter which of these landfills is bigger. By detecting from space which of these nothing has been done and something has been done, we can accelerate climate progress by making smarter investments. And we find a very consistent pattern that it's often about wealth.
Yeah, well, look, to do a brief overview of methane, of course, it's the second biggest problem. CO2 is the biggest, but methane deserves much more attention. And these are the sources of human-caused methane. And you can see fossil fuel extraction and related activity as the worst. Waste dumps, a big one. We just talked about that. And if you look at coal mining, even before the coal is burned, if it's just sitting there in a pile, the emissions of methane from the coal piles and the mines is twice as high as all international aviation combined. So that's an interesting detail. And of course, it's really significant because even though it has a shorter lifetime, each molecule of methane is 82.5 times as powerful in trapping heat. And that means that when it leaks in the fracking or production process and pipelines and the use, then it can be as bad or even worse than coal. So methane deserves a lot more attention. And it's getting more attention.
That's why we're excited there's so many new methane spotting satellites going up. And what's really interesting is we're starting to see the emergence of two classes. So new satellites like Carbon Mapper's Tanager 1 are highly, highly accurate and target at an individual facility. So if you point them at a highly emitting oil and gas leak, for example, you can get very actionable information. But about 99% of the methane emitting sources worldwide will never be observed by a targeted satellite like this. So by combining them with other information from Sentinel, GHGSat, Emit, and others, what we at Climate TRACE can do is get a picture of all the methane emitting facilities in the world. And for each individual state, city, and inventory, we can say, what are your biggest things that you can do to reduce emissions? And that's the power of combining it with many different data sets.
Yeah, and we use 300 satellites, and a lot of these other satellites that focus on individual targets are able to find what to look at by looking at the Climate TRACE inventory. And as I say, we use satellites from, what, 6 different countries? 300 from maybe eight different countries. I want to give a shout out to Will Marshall at Planet Labs, who's been particularly helpful to Climate TRACE. Now, we had a global methane pledge in 2020. Well, what's happened? Well, methane emissions have gone up 5% since the methane pledge, so we really have to focus more attention on this. And obviously, this is a time for all of us to have an awakening. We need to think differently about this. We need to set our priorities differently, because the IEA tells us, you know this, we have all the technologies we need with proven deployment models to reduce emissions in half in the next decade. So we need to get busy and do it. The IEA has formulated a detailed plan. I'm not going to focus on every single one of these. You can read them afterwards. This is going to be available to you all, but I want you to know there is a detailed plan, and it's not a pie-in-the-sky, moonshot type adventure. These are all things that most of them we should be doing for other reasons anyway. We have a plan. We have the technologies. We have the proven deployment models. We need more political will, and I'll come back to that shortly. But the point is, we know how to do this. We know how to get to net zero. And globally, wind alone could provide 40 times as much electricity as the world uses every year. Solar, you may know this story. 22 years ago, the best projections were we could add 1 gigawatt of solar per year by 2017. We beat that goal by 17 times over. Last year, we beat it 445 times over. This is a breakout, near miraculous success story. Cheapest electricity in the history of the world. And by the way, if you look at why, the cost continues to come down. And China, in the first 10 months of this year, in every single month, China has deployed as much new solar electric capacity as would be provided by 18 1-gigawatt nuclear plants built every month. That's astonishing. They've doubled their rate over the previous year. So did the US, by the way, but from a lower base. This is a great success story. And if you rely on coal, it takes if you look at what you get from 100 coal ships, It would take only 50 LNG tankers. It only takes one container ship to deliver the solar PV modules that you would need to get the same electricity that you get from 100 coal ships. And once you get them and set them up, guess what? You have no annual fuel cost, no supply chain risk, no price volatility. And we get enough in 1 hour from the sun to fuel the entire global economy for an entire year. So it seems like a pretty easy choice. And it turns out to be that last year, if you look at all the new electricity generating capacity installed worldwide last year, 87% was clean energy. We are winning on this front. We have these tools, and carbon-free sources are now providing more electricity than either coal or methane gas. Electric vehicles, again, people say, well, the rate of increase slowed a little bit. Not much. They're really beginning to take over. Batteries are coming online and getting much cheaper. This is what's happened, and this is what is in the years just ahead. This is a trillion-dollar industry unfolding right before our eyes. There was one gigafactory in 2016. Now, around the world, there are 240 gigafactories and another 161. There was one, now we have 400 either up or soon to be in the running. The investments in energy are twice as high in renewable energy as in fossil fuels worldwide, but that ratio, according to the IEA, needs to move to 10 to 1. And I hope we can do that as quickly as possible. But we're subsidizing fossil fuels still. It's insane, really, to force taxpayers around the world to subsidize the destruction of human civilization. What sense does that make? Obviously none. We need to eliminate the direct and indirect subsidies. And by the way, I just have to make this point. We keep hearing, oh, emissions are not a problem. We can just suck the emissions back out of the air. We can catch them coming out of the smokestack as they're going up in the air. Or we can just build a giant mechanical vacuum machine. Well, come on. We get used to thinking that technologies all come down in price quickly and miraculously. Some do. Computer chips, you can choose your own examples. But many do not. And Oxford University did a survey of all these technologies, and they found that carbon capture and storage is an example of what they call a non-improving technology. For 50 years, there's been no reduction in cost. And of course, the direct air capture is just simply ridiculous. I mean, if you want to fall for that, I got a bridge I want to sell you. But if you look, oh, now, does this mean that there couldn't be a breakthrough? Maybe. I wouldn't bet on it if it hasn't happened in 50 years. And in the last 20 years, there's been a little bit of progress. I want to give them credit. 20 years ago, they were able to capture 4 hours worth of annual emissions. And now they're able to capture 11.9 hours of annual emissions. How does that compare to the actual emissions? So those two little pathetic slivers on the left are what we're supposed to bet the future of humanity on in order to avoid doing anything that might reduce the burning of fossil fuels. And the fossil fuel industry that has spared no expense to try to capture the process, you know, they're way better at capturing politicians than emissions. They've gotten pretty good at capturing COPs also, by the way. But if we get to true net zero, the temperatures on Earth will stop going up almost immediately. 3 to 5 year lag. They used to think it would keep going with positive feedback loops. No, we can stop this. This is what you would call a thermostatic system. It is controlled by a thermostat, not a knob on the wall, but a set of decisions that regulate how much fossil fuels we're burning. We're still dialing that up, so we're turning the heat up. We can dial it down. It's thermostatic. We can do this. And if we get to true net zero and stay at true net zero, this is not well known. It is fantastic. We could see half of all the anthropogenic CO2 fall back out of the atmosphere in as little as 30 years. You talk about carbon removal. passive, nature-based carbon removal is the strategy we need to follow. We just have to decide how long the world is going to cower in front of the financial and political power of the fossil fuel industry. If we can find it within ourselves in every country to come together and make intelligent choices, we can solve this. And as Jay Inslee said, yes, we had an election in the US, but here's why he says they won't be able to stop. When Trump was president last time, the solar and wind expansion and EV continued anyway because economics are driving it and because state and provincial and city governments and companies are driving it. We're seeing 100,000 jobs already created and in the works in the US because of the legislation to stop climate. And worldwide, we're seeing the rapid rise in clean energy jobs overtake dirty energy jobs. And we're seeing people all around the world continue to demand that we respect their future. And that's why we are so excited to share this data from Climate Trace with you. We invite you to go to the website. And is it expensive to get this data?
It's free.
It's free. Go to your website, Climate Trace. We raise the money, and no fossil fuel money is involved, just from people who want to solve the climate crisis. Now, let me say one final word. All of you here play key roles in determining whether or not we solve this. Thank you. Do not be discouraged by any temporary political setbacks. We have to do this. We have no choice. We can do this. We have the technologies, the models, the policies. We know what works. The only thing that is in any doubt in some people's minds is political will. But you know, every morally based movement in human history has gone through periods of despair when the advocates felt, oh my gosh, will we ever be able to do this? At a comparable moment in the civil rights movement, Martin Luther King Jr. in my country spoke up and he said, keep going. If you can't fly, run. If you can't run, walk. If you can't walk, crawl. But keep going forward. And if you doubt for one moment that we have the political will necessary, remember, political will is itself a renewable resource. Thank you very much. Thank you.